All right. So streaming has started. We will begin with week 11. Okay. So this is the second session of week 11. So today we will explore inverse trigonometric functions, hyperbolic functions, and inverse hyperbolic functions. All right. With some examples, and we'll see some graphs and everything. Okay. So let me share my screen. I hope my screen is visible to all of you, right? Yes? No? Am I
Yes,
audible?
sir.
Okay. All right. So I expect at least one or two of you would reply me. Okay. So as I was saying, so week 11 is all about different types of functions, right? So what all functions that we have studied? So we started with trigonometric functions, and then inverse trigonometric, and hyperbolic, and inverse hyperbolic, right? Primarily we saw these four types of functions, and within each type there are different functions like sine, cos. For example, trigonometric has sine, cos, tan, and inverses of all those things. Sorry, reversals of all those things, like 1 by sine, 1 by cos, 1 by tan. So these four functions, after looking into them, then we sort of applied our calculus knowledge on it, right? Like we tried to solve some problems on limits, continuity, but we didn't focus much on continuity. But the most important parts are like differentiability, and integration. Right. So we will solve, or we have solved problems related to these kind of topics. So today we will start with inverse trigonometric functions. Okay, and see how to compute limits, how to compute continuity, how to compute differentiability, and how to compute the integrations and all. Okay, each of it. So let's start with discussing what exactly how so what type of functions are called inverse trigonometric functions. Yeah. So what kind of functions? Trigonometric functions we know. What are they? So something like sin x, cos x, tan x, cosecant x, secant x, cot x. Right? So these are the trigonometric functions. Now inverse trigonometric functions are just the inverses of these functions. So like sine inverse of x, cos inverse of x, tan inverse of x, and the others, cosec inverse, and so on. Okay. And basically what these are, so what these are, sin x, cos x, tan x gives us the values, right? So x here is the angle, and sin x gives us a value between -1 to 1. Whereas sine inverse x actually represents the angle, and x takes values from -1 to 1, right? And similarly for cos inverse also, x can take values from -1 to 1. So basically the inverse functions. So inverse functions we would have studied in the earlier weeks. So if we have f of x, if we have a function f goes from d to some, say, d prime, okay, I'm not taking r. So f inverse is like, now d, it goes from d prime to d, right? So this is f of x, and f inverse x is like output will become input, input will become output. All right. And strong note, f inverse of x is not 1 by f of x. Okay. So you should not look it in that way. So f inverse of x doesn't mean that power is -1, so I can take it to the denominator. So that's not how functions work. Okay. So that means sine inverse of x is not 1 by sine x. Okay. So sine inverse x is a different kind of function, and we can also plot the function. So for sine inverse of x, the domain would be x can take only values from -1 to 1, and the output would be, output will happen between -pi/2 to pi/2. Okay. And the graph for this looks like this. So something like this. Right. So since it is inverse, you should always note that it should be the mirror image to sin x curve, right, with respect to y is equals to x. So if this is y is equals to x line, if you draw sin x will look somewhat like this. Okay, so just a mirror image for sin x. So this will be sin x, and this will be the sine inverse of x. All right, and few properties. Sine inverse x is again odd function. So sine inverse of x will be minus of sine inverse x. So sorry, sine inverse of minus x will be minus sine inverse of x. So that is f of minus x will be minus f of x. So which implies it's an odd function. Right, so this is sine inverse. Similarly, you can also plot cos inverse. We can also define cos inverse. Right, so these are just the functions. Like, we will just introduce you to new types of functions, but at the end of the day, I hope most of you know all these things from your class 11, 12. Right? So cos inverse x. So the only thing that matters here is the domain and the codomain. So that's the major part. Okay. So that's where people get confused. So for cos inverse, the domain will be -1 to 1, whereas the codomain would not be from -pi/2 to pi/2, rather it would be from 0 to pi. Okay. And plot also, we can plot it. It will simply look like this. You just have to take the inverse. Like, if you don't know how to plot this, this is the best way to plot. So firstly, what you have to do, you draw this y is equals to x line. Okay, so once you have this y is equals to x line, we know how to plot cos x, right? So try to plot cos x. cos x will look something like this, right? And 0 to pi, it will have this kind of shape. Right now, what you have to do is you just have to reflect it with respect to this y is equals to x line. That's it. Okay. So if you reflect it, and you have to reflect it between -1 to 1. That so because the domain is from -1 to 1. So if we are plotting cos inverse of x, the x-axis should be plotted from -1 to +1. That's it. So we cannot go beyond left of -1 and right of +1. So if you fix your -1 and +1, then this part and this part you shouldn't consider. And if you reflect this with respect to y is equals to x, you will have something this kind of shape. Right? If cos inverse of 1 will be 0, whereas cos inverse of -1 would be pi. So this will be pi, and cos inverse of 0 will be pi by 2, and cos inverse of 1 would be pi. 1 would be 0. So this is 1, this is 0, and this is -1. And you just erase all the unwanted parts. Okay. So most of you know this, how to plot this. But if you are confused how cos inverse x, sin inverse x look like, then you can follow this method. Alright. And cos inverse of -x is slightly different. So this would be pi minus of cos inverse x. Okay. So these are again very easy to verify. So you can actually verify this and check. So you take -1 and you see whether it satisfies or not. So cos inverse of 1 on the left hand side, pi minus cos inverse of -1 on the right hand side, both will be 0. And you can check for other values also, it will satisfy. Alright. So similarly we can plot for tan inverse. So once we plot for sin inverse, cos inverse, tan inverse, then the other cot inverse, cot inverse, cosec inverse, secant inverse would be very straightforward to understand. So if we can plot tan inverse x also, it will look somewhat like this. Just a second. So tan inverse x will look something like this, right? So this will be this and this. And again, the most important part is identifying the range and the domain. So the domain for tan inverse of x is from -infinite to +infinite. Okay, because the range for tan x is -infinite to +infinite. So this will, and the values would lie between -pi/2 to +pi/2. Okay, and this is how the graph, and maximum value that tan inverse x can take is pi/2, and the minimum value that this can take is -pi/2. Right. So once you have these three, then we can actually write cosecant inverse. Right, cosecant inverse of x is simply sine inverse of 1 by x. Right. Similarly, secant inverse of x would be cos inverse of 1 by x, and cot inverse of x would be this is, I think this is slightly different. This would be pi/2 minus tan inverse of x, tan inverse of 1 by x. So week 11 is all formulas. right? So personally, I won't like, but sometimes you just have to cope up. All right. So these are few formulas that you don't need to mug up. If at all we ask any question related to this, we will just give you as a hint. Okay. But it's important to understand why this is happening. Okay. So yeah. So these are majorly the inverse trigonometric functions. So once we know what inverse trigonometric functions are, then we can apply our knowledge of calculus on these kind of functions. Right. So then we can talk about derivatives and integrals on inverse trigonometric functions. Right. So this is main important skill that you have to develop. So not how these formulas are working. So instead of mugging up these formulas, the thing is you should be able to know how to take a derivative of some inverse trigonometric functions. So how to integrate an inverse trigonometric functions. Okay, so that's the skill you should develop. And these a simple sine inverse of x, I think professor has proved in the lectures. So just take a look at it. Just understand how the derivation is happened. Okay, and then you will be able to appreciate the result. Here in this today's lecture, I will just show the results, but I recommend you guys to go back and watch that lecture and see how to get the derivative of an inverse trigonometric functions. Okay. So for sine inverse of x, if I take the derivative with respect to x, the result would be 1 by square root of 1 minus x square. And looking at the result, it looks like magic has happened, right? So you won't appreciate that much. So it looks like some ugly formula. But when you carefully look at how we derived this particular formula, then you will definitely appreciate the result. Okay. So once we get this, then we can also talk about derivative of cos inverse x. Okay. So in lectures, I think professor would have written sine inverse of x prime, cos inverse x of prime, which is nothing but the derivative, right? Even this is also minus 1 by square root of 1 minus x square. So all these are quite important formulas, but rather than looking them as formulas, you should definitely understand how that formula has come. Okay, so tan inverse of x is also 1 by 1 plus x square. And once this is 1 by 1 plus x square, cot inverse of x derivative is minus 1 by 1 plus x square. Right? And this is with respect to derivatives. And with respect to integrals, we can also talk about the integrals of inverse trigonometric functions. Uh, Sorry, rather than integrals. So how this inverse trigonometric functions help us computing integrals, basically. Okay, so once we know the derivatives are like this, so the derivative of sine inverse x is 1 by root over 1 minus x square, then the integral of 1 by root over 1 minus x square dx would be sine inverse of x plus some constant, right? Not only this, we can also compute integrals which are of the form a square minus x square dx. Now what we have to do is we have to pull out a square out right? Then this will just become 1 by, so if I just pull a square out, I will have root a square into square root of 1 minus x by a whole square dx, right? So then this a square, square root a square will come out and become a, and this will just simply be 1 by a integral 1 by square root 1 minus x by a whole square dx. Now you just have to simply do a substitution. So put some k is equals to x by a. Now dk will be 1 by a dx, right? Then dx would be a dk. If I just substitute them, I will simply get 1 by a integral 1 by square root 1 minus x by a is k. So this will simply be k square, right? So this x by a, we just replaced it with k. And now dx is a dk. So this will become a dk. And this will get cancelled. And what we eventually get is integral 1 by root over 1 minus k square dk. And we know the integral of this, which is simply sine inverse of k plus c. And you replace k by x by a, we will get, right? So instead of k, you just write or replace x by a, we will get sine inverse x by a plus c. So these kind of integrals previously we were unable to compute, right? So if we have these kind of expression in the denominator, it's hard to get the integrals. Now sine inverse functions will help us. Not only sine inverse, inverse trigonometric functions will help us computing these kind of integrals. Okay. So similarly, we can also compute integrals of type this type. So 1 by 1 plus a square, 1 plus x square. Okay. And for this will be 1 by 1 plus x square. It is the derivative of tan inverse of x, right? So if I integrate 1 by 1 plus x square, I should get back tan inverse of x. So this will be tan inverse of x plus some constant, integration constant. And if I have a square instead of 1, if I had a square, then instead of x, we will have x by a. That's it. All right. And the other integral, which we can, yeah, I will paste the YouTube link in the calendar. And the other integral which we can compute is 1 by x into square root x square minus a square dx. So this is slightly tricky, but we, after certain substitutions, we can actually reduce this as secant inverse of x by a plus c. Okay. And a point to note that you see this particular x square minus a square in the denominator. So square root of, it's under the square root. So this should be greater than 0. So that's the only condition. So you need to have your x square to be greater than a square. Then you can perform the integral. And this is how the integral looks. Okay. So even these are also explained in the lectures. Okay, I'm just giving a brief overview of the integrals. All right. So far what we saw is the inverse trigonometric functions and how to take the derivatives, or what are the derivatives of inverse trigonometric functions, and how inverse trigonometric functions help us finding integrals of certain expressions like this. So 1 by 1 plus a square plus x square, and 1 by square root of a square minus x square, and 1 by x into square root of x square minus a square. Okay. So this is about the inverse trigonometric functions and their and some calculus on inverse trigonometric function. Okay. So the next type of function which we are going to see is hyperbolic functions. Any doubts in inverse trigonometric functions? Anybody? All right. So let's discuss hyperbolic functions now. And hyperbolic functions are defined like this. So sine x, and there will be h just before x. Okay. So h represents hyperbolic. So this is sine hyperbolic. All right. So that is the denotion, and this is defined as e power x minus e power minus x by 2. Okay, so that's the definition of sine hyperbolic of x. Similarly, cos hyperbolic will be denoted like this and defined as e power x plus e power minus x by 2. All right, and if you see the graphs of this, there is a very good connection to trigonometric functions. Right, so trigonometric functions, we know how we define trigonometric functions. So we just, if this is theta, this is theta, then, and this is unit circle, right? Unit circle, I mean, this is length 1. Then we define this point as sine theta comma cos theta. Then this is sine theta and this is cos theta. So that's how sine theta and cos theta are defined. And if we look at sine hyperbolic of x or completely plot sine hx, then this would look like this. Right? Right. So any point you pick. So for that value of x, this y-axis gives you the sine hyperbolic of x. All right. And sine, when we write this in, we can actually write this in power series forms also, because once e power x comes into the picture, we know the power series expansion of e power x, which is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Right? Then we can actually compute or write sine hx in power series form, which is e power x minus e power minus x by 2. So e power minus x is not e power minus x also we will write. Okay, so e power minus x will be 1. Instead of x, you just have to write minus x. So then we will have 1 minus x by 1 factorial plus minus x whole square, which will be x square by 2 factorial plus minus x whole cube, which gives us minus x cube divided by 3 factorial and so on. So if we do e power x minus e power minus x, the terms that get cancelled will be this one. So even powers will get cancelled out. Only the odd powers will remain, and odd powers will be twice. So each term will be twice. And if you divide it by 2, you will get each term once. So the result would be x by 1 factorial plus x cube by 3 factorial plus x power 5 by 5 factorial and so on. Only the odd power summation. Similarly for cos x, cos hyperbolic of x, which is e power x plus e power minus x by 2, you will get only the even powers. So 1 plus x square by 2 factorial plus x power 4 by 4 factorial plus and so on. Okay,
Sir, it
so
would be 2, right?
which one would be 2?
That 1. 1 plus 1 will be 2.
Divided by 2. We have divided by 2, right?
Oh, okay, sir.
Alright. So now how we define tan hyperbolic of x is just like how we define tan x. Right? So there is no change. So tan hyperbolic of x is simply sine hyperbolic of x divided by cos hyperbolic of x. Okay. And this would be e power x minus e power minus x divided by e power x plus e power minus x. Okay. And similarly, secant hyperbolic of x is simply 1 by cos hyperbolic of x. Cosecant hyperbolic of x is 1 by sine hyperbolic of x. Everything is same as trigonometric functions. But the changes comes with identities. So you would have studied this from class 8 or 9. So sine square theta plus cos square theta is 1. Right? Coming to those identities in with respect to hyperbolic functions, there will be a slight change. So identities. So the first identity would be cos hyperbolic square of x minus sine hyperbolic square of x will be 1. So it's not plus, it is minus. And we can cross check this. So you know what cos hyperbolic of x expression and you know sine hyperbolic x expression. You just write it and square it and see the difference. You'll get 1. Similarly, there are other identities also, useful identities, which are secant hyperbolic square plus tan hyperbolic square of x will be 1. So in trigonometric functions, we would have seen secant square x minus tan square x is 1. Here it is plus. Okay. And the last identity is cot hyperbolic square of x minus cosecant hyperbolic square of x would be. Okay. So these are some useful identities. And yeah, so basically this is all about hyperbolic functions. And now we should know how to take the derivatives of hyperbolic functions. So everything, once we learn the functions, the next thing we are going to do is using our calculus knowledge on it. Right? So we will do that. Ah. So yeah, we will do that. And am I missing something? Okay. So let me discuss this thing also here. So out of this, all the hyperbolic functions, some are even functions and some are odd functions also. Right? So let us put them, classify them. Okay. So among these hyperbolic functions, few functions are even functions and few are odd functions. And even functions are only cos hyperbolic of x and 1 by cos hyperbolic of x, which is secant hyperbolic of x. Okay, so how to check even and odd? I hope you all know. You just have for even, the condition that you have to check is your f of x should be your f of minus x. Whereas odd, you have to check whether your f of x is minus f of minus x or not. So I have written it in slightly different way, but I hope you can get it. Okay. So all other hyperbolic functions are odd functions. Alright. So what are the other remaining? So they are sine hyperbolic of x and cosecant hyperbolic of x and tan hyperbolic of x and cot hyperbolic of x. So these four will be odd functions, and cos hyperbolic of x and secant hyperbolic of x are even functions. And let us also finish inverse hyperbolic functions and then commonly talk about the derivatives and integrals. Okay, so let's also talk about the inverse hyperbolic functions. So inverse hyperbolic functions are also same like inverse trigonometric, right? Inverse functions are that. Inverse means power minus 1. Okay, so you can always, whenever inverse comes into the picture, it is actually something power minus 1. So here the inverse functions that we are going to see are sine hyperbolic inverse of x, cos hyperbolic inverse of x, and the other, all the hyperbolics inverse functions. And again, proofs, there are many proofs, and even in the lecture also professor has intuitively proved how these inverse functions are defined. Okay, so basically these inverse functions are like this. So sine hyperbolic of h, sine hyperbolic inverse of x is, I think, log x plus square root x square plus 1. Right? So again, so I'm not proving it. So looking at the result, it looks very, very vague. I understand. But proving things kills more time. So professor has already proved this. So I suggest you guys go back to the lecture and see how this has come. Okay. And also cos hyperbolic inverse of x, which is log, again this, there is slight difference. Instead of x square plus 1, this will be square root x square minus 1. So the here we should be slightly careful. Okay, so this x square minus 1. So here x square plus 1 is positive anyway. So for any x square plus 1 will be positive. So no need to worry. But here x square plus 1 and also x square plus 1 is greater than x. So it doesn't matter. So x plus square root x square plus 1 will always be positive. Okay, so for any x. So we don't need to worry about here, but we have to worry here. So here x square minus 1 cannot be negative. So my input should be greater than 1 because x square minus 1 should be greater than or equals to 0. So my input should be, my x should belong to 1 to infinite. Okay. And even my range, if I see the range, okay, so this x plus square root x square minus 1 cannot or will always be greater than 1, greater than or equals to 1. Okay, so the range will also be restricted to 0 to infinite. Okay, so you just take random value of x and see. Right, so once x is greater than 1, this part is greater than 1. Okay, and 1 plus something will always be greater than 1. Correct. So once it is the inside, log of inside is greater than 1, greater than or equals to 1, then definitely log value will be greater than or equals to 0. So this will be the range, and this will be the domain. So cos h inverse of x will grow from 1 to infinite to 0 to infinite. Whereas sine inverse of x, sine hyperbolic inverse of x can take any real value and it can output any real value. Okay. So that is cos inverse. And similarly, there are other formulas also. So I don't want you guys to stare at the screen just looking at the formulas. So you can just go through the formulas in the lectures. If you have any doubt, we can discuss regarding that formulas, how that came or anything. So there are formulas for tan hyperbolic inverse, cot hyperbolic inverse, secant hyperbolic inverse, and so on. Okay. So you just go through it. Now let's talk about the derivatives of this hyperbolic and inverse hyperbolic functions. So any doubt so far? Is it boring? Am I discussing only the formulas? What else? Week 11 is all then.
No, sir.
Okay. So we will do things in week 12. So week 12 is quite interesting. So we will get into a new concept or new field in mathematics, which is ordinary differential equations. Okay. So let's finish up. Let's finish this derivatives of hyperbolic and inverse hyperbolic. Okay. So sine hyperbolic of x derivative is nothing but you have to take the derivative of e power x minus e power minus x by 2's derivative. Right? And we know how to take the derivative of this. So e power x is e power x, e power minus x is minus e power minus x, and minus minus will become plus. So this will become e power x plus e power minus x by 2, which is cos hyperbolic of x. Right? Sine hyperbolic of x derivative is cos hyperbolic of x. Similarly, if I compute cos hyperbolic of x derivative, so this is e power x plus e power minus x divided by 2 derivative. If I take the derivative, e power x is e power x plus e power minus x is minus e power minus x by 2. Right. So this is, if I simplify this, this will just be e power x minus e power minus x divided by 2, which is sine hyperbolic of x. So this is slightly contrast to derivative of cos x. Right. Cos x derivative is minus sine x, whereas here cos hyperbolic of x derivative is just sine hyperbolic of x. Similarly, we can take the derivatives of others also. So tan hyperbolic of x and cot hyperbolic of x, everything. So we can actually compute the derivatives of the hyperbolic functions. Right. So tan hyperbolic of x would simply be secant hyperbolic square of x. So everything would be almost the same, but you should be slightly careful about the signs. Sometimes signs will really screw us. Okay. So I'm not writing this. So you can fill this particular page also. And we can also talk about the derivatives of inverse hyperbolic functions. Right. So cos hyperbolic inverse of x derivative would be, so you have to take the derivative of, so we just discussed, this is log x plus square root of x square minus 1, right? So you have to take the derivative of this. So if I take the derivative of this, logs derivative, so it's just the composition of many functions actually. So you have to take the derivative carefully. So the outermost function is log x. So log x derivative is 1 by x. So where x is basically the whole whatever is inside log. So this will be 1 by x plus square root x square minus 1, and you have to take the derivative of whatever that is there inside. Right. So if we finally do a series of steps like this. So now if I take the derivative, so x derivative is 1 plus the derivative of square root x square minus 1. Again, we have composition of many functions here. So if we solve this, we will get 2x by 2 into square root x square minus 1. So I have skipped some 3-4 lines. Okay, so this and this will get cancelled out. And if I simplify this further, you will see that 1 by x plus root x square minus 1, and on the right hand side, on the this side also, you will have square root x square minus 1 plus x divided by square root x square minus 1. So now you will observe that this and this will get cancelled out. And finally, this result is important. So x square minus 1. And also, when we are talking about cos hyperbolic inverse of x, our x should be greater than 1. Right? So that this also makes sense. So square root x square minus 1 will be the derivative. So previously, we had seen 1 by square root of 1 minus x square. Right? So that's the derivative of sine inverse of x. And cos hyperbolic inverse of x derivative is 1 by square root of x square minus 1. Okay, so this is what confusion is. So everything is like minus to plus, plus to minus, 1 minus x square to x square minus 1. So you just have to be really careful while you compute. So that is why it is always better to know how to compute rather than the result. Okay, so similarly, sine hyperbolic inverse of x derivative also you can compute. And finally, again, many cancellations will happen. Finally, you will get x square plus 1 whole root. And this x can take any real value. Okay, so these results will help us in computing integrals of these kind of functions. So if I take the integral of the right side, then it will give me the sine hyperbolic inverse of x. Okay. So similarly, again, tan hyperbolic inverse of x, cos hyperbolic inverse of x, everything comes. Okay. So yeah, so that's more of what is in week 11. So week 11, again, as I said, week 11, at least in my personal opinion, I don't feel interesting in this. In the sense, I don't like formulas, basically. So, so the most important or interesting part is how we compute integrals. So in computations, this will be fun. Okay, so maybe we will solve a couple of problems in practice, or if you have any doubts in activity or practice, you can ask me. We can try to solve it. Okay. Any doubts? No silence. Okay. All right. Then what shall we do? Shall we take some replicas of graded assignments and try to solve them? Okay. So I will try my best. So I haven't prepared any questions. So I will try my best not to reveal the actual answers. Okay. So let's do problems related to week 11. Okay. And not to mention, don't think that we didn't want you guys to remember formulas or something, or we are not giving too much importance to week 11. Don't think that it won't be asked in end term exams. Okay. So questions will be there from week 11 also. Okay. So that is all the very first problem itself. I'll slightly modify it. So let's say you have cot x plus cos x as some p and cot x minus cos x as q. Okay. Now, let's say you find or give me p square minus q square. Okay. So I think this is the very first question in your graded assignment, right? So you can try solving this, and I will also solve this particular problem in some 5 minutes or 2 minutes. Okay, I hope people are trying to solve this particular problem. Okay, let me.
Yes, sir.
Yeah.
Sir, its answer is in integer type.
It's not integer type. Okay, I will just give you options also. So it's way better to give it as options. So let me put the options. So let's say question is which of the following options are correct? Okay, so option A, let's say p square minus q square is 2pq, and option B, p square plus q square is 4 root pq, and option C, p square minus q square 2 root pq, and option D, p square minus q square is 4 root pq. Okay. Okay, let me put this also. Option E, none of this. Okay. So for my safer, so this is my safe option. Okay. So those who are trying, you guys can try. Those who want the solution, just wait, just take a break of 2 to 3 minutes and come back. All right. So, any answers?
Sir, I think it will be none of these.
None of these. Huh? Okay. All right. Anybody else who tried this? No. All right. So let's try to do this. So if you know how to do this, then question 1 in the graded assignment is easy for you guys. So let's see. So we have cot x plus cos x is p and cot x minus cos x is q. So from this it's just a system of two linear equations. Okay, so we can solve for cot x and cos x. So if you just add these two equations, you will get 2 cot x as p plus q. So from there you will get cot x as p plus q by 2, right? And similarly, if you subtract the second equation from the first equation, then you will get cos x, which will be p minus q by 2. So once you reach this point, now the question is, which of the following options are true basically? So we have to, if you see the question, it is connection between p square minus q square and p square plus q square. Those are the things they wanted, right? So if I just take cot square of x, so this will be p plus q by 2 whole square, right? And cos square of x will be p minus q by 2 whole square. So if I need p square minus q square, so these things are just the tries. Okay, so you can try it in this way and see whether we are going to get successful or not. So if I need p square minus q square, so if I just multiply these two, right? So if I just multiply cot square x to cos square x, on the right hand side I will get p plus q by 2 whole square into p minus q by 2 whole square, right? And I know what cot square in terms of sine square and cos square, right? So cot x is basically cos x by sine x. So cot square x is cot square x
Cos
is
square is x by
by
sin square
sine
x.
square x, and there is cos square x here. And on the right hand side you have p square minus q square divided by 2 divided by 4 whole square, right? Now what is cos square? I can further simplify this, right? Or what is sine square? So
1
cos
minus
square
cos
x.
square x.
So this is 1 minus cos square x into cos square x, right? Which is p square minus q square by 4 whole square. Now cos square x I know, which is p plus q by 2, sorry, p minus q by 2 whole square. And divided by 1 minus p minus q by 2. What am I doing? Okay. Okay, this is just a try, right? Let's see whether we are going to get anything. Okay, so we have p square minus q square by 4 whole square on the right hand side. Okay, so it looks like a little complicated, right? So let's So this is try 1. So what we did is basically we tried to multiply and saw whether we are going to get to the solution or not. So the other try is try 2 should be, so the next operation. So multiplication doesn't work. So either we add or subtract these two and see. So if we subtract and see, so cot square x minus cos square x. Okay, so what we will have? We will have p plus q by 2 whole square minus p minus q whole by 2 whole square. Right, so that is what we will have. So again, we will try to replace cot square x by cos square x by sine square x minus cos square x is equals to right hand side. If I expand this, this will be p square plus 2pq plus q square by 4 minus p square plus minus 2pq plus q square divided by 4. Right? So since this is minus here, this p square and this p square will get cancelled out. Q square and q square will get cancelled out. 2pq minus of minus 2pq will give us plus 4pq. 4pq divided by 4. Right? So this and this will get cancelled out. We will have pq on the right hand side. What's on the left hand side is, if I take cos square x common, or yeah, cos square x common. If I take cos square x common, what will I have is 1 by sine square x minus 1, right? And this will
Yes,
be
sir.
cos square x 1 by, so if I simplify this, I'll get, if I cross multiply, I get 1 minus sine square x in the numerator, which is nothing but cos square of x divided by sine square of x, right? And this is cos square of x into cot square of x, right? So that's what we have. And what is cos square of x? Cos square of x is p minus q by 2 whole square. And cot square of x is p plus q by 2 whole square. Right? And also we solve this. Cos square x, cot square x into cos square x is going to be p square minus q square divided by 4 whole square. So this will be p square minus q square divided by 4 whole square. And what is this? This is the left hand side. So this is LHS. And on the right hand side, this is RHS. So LHS is actually equals to RHS. So we'll have p square minus q square by 4 whole square is actually equals to pq. Right? Now if I take the square root on both sides, I'll have p square minus q square by 4 as square root pq. Now if I take 4 also to the right hand side, this will be p square minus q square 4 times square root pq. So the first problem, you just have to try your luck in some sense. Or the other way, what you can do is, you know what p is, you know what q is, right? You just substitute and see. So p square is basically cot x plus cos x whole square, and you know q, which is cot x minus cos x, take whole square of it, then simplify it, and finally you will reach this point. So something like some expression, and identify how to get that expression just in terms of p and q. Okay, so that is also another way. Finally, the answer is option D. Okay, so yeah, this is how We solve this particular problem. All right. So let's solve one more question. Okay. So even if you guys have any questions, you can ask me, or else I'll take my own question. So let me see. So I have to generate now. Okay, so let's solve third problem. So this is a replica of GA question 3. So this question basically talks about how we can convert from one trigonometric function to another trigonometric function. All right. So what will be sine inverse of 4 by 5? Okay. So if it is tan inverse of x, then find x. Okay. So let's say this is subpart. Okay. So if sine inverse of 4 by 5 is equals to tan inverse of x, find x. This is very simple. So maybe you can take some 1 or 2 minutes. Okay. I hope this can be solvable by most of you. So if you know the right angle triangle, then you can do this easily. Let me see. Okay. Yeah. Anybody else except Ananya? Shivkumar, Chetan, Rajdeep. Okay. Tell me one thing. Do you guys solve this, or you just feel like this is so easy to solve? Okay, are you guys there? Let me just check now. Just raise your hands if you are in the session. All right. All right. All right. Okay. Okay. So let's see. Let's not waste too much time on this. So sine inverse of 4 by 5, as we said, so this actually represents an angle. So this is an angle, right? And the inside one is the value of the angle, right? So if I have a right angle triangle, right? And if this is theta, let's say this is base A, B, and C, most of us or everybody of us know what is sine theta. Sine theta is simply opposite by adjacent, opposite by hypotenuse, right? So now theta would be, so if I take sine inverse on both sides, I will have theta as sine inverse of B by C, correct? So sine inverse of 4 by 5. So now what you can take is B value you can consider it as 4, C value you can consider it as 5. Right, so now your right angle triangle will just be, sorry, this won't be the right angle. Okay, so this is 4 and this is 5 and this is theta, correct? So once if this is 4 and this is 5 and this is right angle triangle, again we all know that this very own old formula, a square plus b square is actually equals to c square, correct? If you use this, then you will see that this will be 3. Now you can write down what tan theta is. So tan theta is
Perpendicular upon base.
opposite by adjacent. Now from here I can actually compute theta in terms of tan inverse. So this is tan inverse of 4 by 3. Correct. So our theta is sine inverse of, sorry, I didn't write. Theta is sine inverse of 4 by 5. Our theta is tan inverse of 4 by 3. So therefore sine inverse of 4 by 5 will be equals to tan inverse of 4 by 3. Hence our x will be 4 by 3. So the answer is 4 by 3. Alright, so this is how you should convert. So let me take, so within that itself, let's do one more conversion. So let's try to convert let's say part B is, we have cot inverse of this is 8. So what's the other triplet? Pythagorean triplet? So that comes with 12, not 12. Ananya, what's the other kind of triplet possible for the right angle triangle with integer values?
5, 12, 3, 13.
5, 12, 13, right? Yeah,
Yes,
correct.
sir.
Yeah. 5 and 12 and 13, right? Okay. Thanks. So let's say cot inverse is cot inverse of 13 by cot inverse of 12 by 5 to cosecant inverse of y. Now find y. So this is slightly tricky, but we can find. Okay, so these conversions are very important. Okay, so you just take a minute, try to get the answer. If not, then we will. Yeah, just wait, Ananya. So anybody trying this? Shivakumar, Chetan, or anyone? See
Yes,
new
sir. Checking,
people.
sir.
Yeah,
Working, sir.
I see new people in the meet. Sohan. Sorry, this is. Excuse me if I spell this wrong. Okay, they both three. Is that correct?
Yes, sir. Yes, sir.
Okay. Okay. So try to do this. So just put it in the right angle triangle. So this is the best way. Try to get that theta in terms of sine, cos, and everything. Once you can able to write that in all trigonometric functions, then inverse would also be very simple. Okay, so the hint is, instead of looking for cosec inverse of y is basically sine inverse of 1 by y. So this we have discussed earlier in this lecture, in this session, right? So now what you have to do, what you have to come up with is, if we can write cot inverse of 12 by 5 as some sine inverse of something, then that something I will equate it to 1 by y and find y, right? So that's all I have to do. Let us put this in right angle triangle. Now we are interested in this theta. Okay, and again A, B, C. So what is cot theta? It will be adjacent by opposite, right? So that would be A by B, right? So theta will be cot inverse of A by B. Now in our case, A is 12 and B is 5. Correct. So A is 12 and B is 5. And the triplet would be the third one. Hypotenuse would be 13. So this is cot inverse of 12 by 5. Right. Now what we have to do is, we have to write this theta in terms of sine inverse. So for that we need to compute sine theta. So what will be sine theta? It is opposite by hypotenuse, which is 5 by 13, right? And from here theta would be sine inverse of 5 by 13, right? Now these two are the same. These two are same. So that means cot inverse of 12 by 5 is actually sine inverse of 5 by 13. Now what we have to do is, we have to equate this 1 by y to this 5 by 13. Therefore 1 by y is 5 by 13. This implies y is 13 by 5. This will be our answer. Right, so this is how we can move from one inverse trigonometric function to another inverse trigonometric function. Okay. So that's second question that we discussed from GA itself. So it's like, now you can be able to solve the third question in the GA. Okay. Then all right, let's do question number 8, which has hyperbolic functions. Okay. So question 3 for today, and this is kind of replica of question 8 in G11. Okay, so let's take two functions. Let's take f of x to be 2 minus sine hyperbolic of x, and g of x to be 2 plus sine hyperbolic of x. G of x, we take it as cos hyperbolic of x. Okay. So let's see, let's compute. We will try to compute integral of f of x plus g of x dx. So this is first part. And then we will compute f prime of x, and then we will compute g prime of x. Okay. And yeah, so let's do these things. and find the intersection point. So this is slightly new. So let's do this also. Okay, so there are 4 parts. Now the time is 9:28. So try to solve each and every part. Okay, so take some 5, maybe some 7 minutes also. 9:35 we can discuss this particular problem. And then we will solve one more problem, and by then we will reach 10 p.m. Okay, so try solving this. So we have discussed this, right? So we know how 2 plus sine hyperbolic of x behaves and how cos hyperbolic of x behaves. We can actually compute part A, part B, part C. Once you are done with part A, part B, part C, then think of how to get the intersection point. Anybody finished?
Sir, I finished 3 of them, but I don't know fourth one. I
Okay.
think we have to f of x is equal to g of x, right, sir? But I don't know how to do that then.
Okay, so a small hint at this point for option D. Okay, so try to write sin hx as e power x minus e power minus x
Loggy
by
2,
2.
sir.
Ah, correct. And cos hx as e power x plus e power minus x by 2. So write it in, instead of thinking it as sine hyperbolic x and cos hyperbolic x, they are just this, right? So try substituting them, and then you just have to use the idea of intersection point. Now you can get it, I guess. I think most of you would have solved first three parts, right? So just the integration. Just now we have discussed this, right? So f of x plus g of x is simply 2 plus sine hyperbolic of x plus cos hyperbolic of x. So you should also look into these kind of functions. So what will be sine hyperbolic of x plus cos hyperbolic of x?
Differentiation. E
It
of
is
x,
e power
E
x,
of, yes sir,
right?
minus e to the power minus 1.
Okay, so e to the power minus x divided by 2 plus e to the power x plus e to the power minus x by 2, right?
Yes sir.
Now I can simplify this, right? So this and this will get cancelled out. I will have 2 e power x in the numerator and 2 in the denominator. This will just simply be e power x. Similarly, cos hyperbolic of x minus sine hyperbolic of x. If you try solving this, you will get e to the power
E to the
minus x.
power minus x.
Yeah. So these kind of things help us solving these kind of problems. Right. So simply f of x plus g of x will now become integral of, we already have 2 plus sine hyperbolic of x plus cos hyperbolic of x, which is simply e power x dx. So this will be 2x plus e power x plus some constancy. That's it. Now f prime of x is, derivative of 2 is 0. Derivative of sine hyperbolic of x is cos hyperbolic of x. And g prime of x is again derivative of cos hyperbolic of x is sine hyperbolic of x. It is not minus sine hyperbolic of x. Okay. So if you are confused, then write hyperbolic functions in terms of e power x and e power minus x. So then it will be easier. Now for finding intersection point, what's the condition?
F of x is equals to g of x.
Correct. So intersection point is attained at f of x is equals to g of x. Now what is f of x? 2 plus sine h of x. And what is g of x? Cos h of x. Right. Now if I take this to the right, left hand side, I will get cos hx minus sine hx is equals to 2. Right. So now just now we saw cos hx minus sine hx is e to the power minus x is 2. Now taking log on both sides, we will get minus x ln 2, and the intersection point will be minus ln 2. Okay. I hope this is clear for all of you. Right. So all right. The other questions are like, if I just give, I was feeling like if I just take that particular question, I might give you the complete solution. But I think most of week 11 concepts are formula driven. So if you know the formula, you can actually do all 10 questions straight away. I don't see any problem in any of the questions. Right? All right. So then I would like to stop here. Any other issues operational wise? Any administration issues? Any portal issues? You can let me know. or else we can end our session here. All right. All right then. Let's not waste both of our prime times. So end term is getting nearer. Okay, prepare well for the end term. Okay, so the major syllabus is from week 9, week 10, week 11, week 12. But there might be one or two questions. So which we will emphasize what concept you should revise from week 1 to 8. Okay. So that we will discuss during the revision sessions. But for now, just focus on week 11 concept, practice more problems, and then move quickly to week 12. So we don't have time. Okay. So it's already 10th December. We hardly have 10 more days. Right. So 22nd December is our final exam. So finish week 12 also as quickly as possible. Yeah, I know. So there will be few days on which we definitely have to cry if we didn't sweat our blood before the before that day. Okay, so let's try to spend some time, and then there will be high chances of doing better in the end. Okay, all right then. Let's meet in the next session.
Thank you, sir.
Yeah, thanks a lot.
Thank you,
Thank you,
sir.
sir.
Have a great day. Yeah, bye.
Thank you, sir.
Thank you.